I got this amp to fix from a friend when it started making a very loud 60 cycle hum after his young child ripped the cord from its input jack. Since I already know the cause of the issue, it should be a relatively straightforward fix, so let's get right into it. After unplugging the amp from the wall, the first thing I did was unplug the speakers, taking note of which wire goes where. By convention, the pair with the white wire goes on the left, while the pair with the red wire goes on the right. Note that since we're looking at the amp from the back, this is reversed. It's also convention that the black wire goes on the negative terminal of each speaker, although in this case they were on the positive terminals. I'm not sure if that was by design or if the last person in here simply put it back together wrong. I decided to leave it as is. In most cases, the important thing is that the polarity is the same between both speakers. On the front of the amp, first remove the nuts from the 2 1/4-inch jacks. Next, remove the knobs from the potentiometers with a pair of pliers. Place a rag between the pliers and the knob so that the plastic doesn't get marked up. Underneath each knob will be a nut holding the potentiometer to the faceplate. Remove each of those next. The faceplate is a bit tricky to remove. First, remove the 4 screws, one on each corner. Then carefully pull it straight forward, being careful not to break the clips behind the 5 buttons that hold it to the PCB. It's just a little bit wider than the space between the corner protectors, which can't be removed with the chassis in place, so you'll have to flex the faceplate in the middle just a little bit to pull it out. Once the faceplate is removed, take out the 4 screws holding the chassis into the cabinet and slide the whole chassis backward and out. Once I got the chassis on the table, I removed the ribbon cable connecting the main board and the control board, and I took out the 4 screws holding the 2 heat sinks onto the chassis. I'm really not a fan of how this is designed. The only thing holding the main board into the chassis are these heat sinks, meaning all the forces are transferred through the pins of the power amp ICs that they're attached to. Carefully pull backward on the main board to slide it out of the chassis. Make sure not to pull directly on the heat sinks, but keep them well supported to avoid breaking any pins. I wasn't thrilled about how much force I was putting on these spade connectors, yet they did not seem to be moving at all, so ultimately I ended up leaving them connected. Looking at the jack, I can see that it is not well seated on the board, and the solder joints on it don't look too great. Off camera, I tried to reseat the jack and redo all the solder joints, but it did not make a difference. With the main board out of the chassis, I was able to start removing the input jack. I start by adding some fresh solder to the joints to help them flow, then I hit each one with the solder sucker. Sometimes trace amounts of solder will still be left behind after this, especially on larger pins such as these ones. After the 3rd or 4th pump, if the pin is still not free, I like to apply some light sideways pressure with a tool to help unstick the pin from its through hole. Once all of the pins freely wiggle back and forth just a little bit in their holes, then the jack is ready to be removed from the board. Very carefully pry between the board and the jack. Don't force it if it doesn't immediately start moving with a small amount of force, otherwise you could lift a pad, damage the board, or the component you are removing. Sometimes only one side will move. If you're lucky, only a single pin will still be stuck and the rest are free. When this is the case, you can use the soldering iron to add some heat to just the pin that is stuck and free it up just long enough to pop the part out. With the jack now removed, it's much easier to clean up the last little bit of solder. I can apply heat from one side of the board and vacuum to the opposite side, rather than needing to pull the iron away at the last second to make room for the pump. The bottom left pad, as seen here, actually lifted from the board. This is not uncommon when desoldering, especially in instances like this where the component suffered mechanical shock. It's quite possible this was already failing and was responsible for the faulty connection causing all of the noise, rather than the jack itself. Sometimes you can reattach these with super glue, which I attempted to do here. In this case, it was not successful, so I ended up replacing that connection with a wire later on. These are what is known as Cliff-style 1/4-inch jacks, after the company that created them. The original is on the left and the new one is on the right. There are plenty of suppliers that make them in this style. I just went to DigiKey, filtered for PCB mount 1/4-inch jacks, and bought the first one that looked right in the picture. For most electronic components, I would recommend a more rigorous selection process, but in this case it ended up just fine. These are just slightly different, but they'll be good enough. The old one has a metal ring around the opening, the new one is entirely plastic. The metal makes no electrical contact with anything else, My guess is that it's there to help prevent the jack from wearing out too quickly with repeated insertions and removals over the life of the jack. For the light use that this amp will see, I don't expect that to ever be a problem. After transferring over the grounding washer on the front of the jack to the new one, it's time to solder it in. I like to solder opposite corners for my first 2 or 3 pins to help physically stabilize the part while I do the rest of the soldering. After that, it doesn't matter what order the rest are soldered in, just be careful not to bridge any of the pins. With the new jack soldered in, it's time to button things up and do a test. Slide the PCB back into the chassis, again being super careful of the heat sinks. The main board kind of gets sandwiched between 2 standoffs on the bottom of the chassis, covered with some kind of felt tape in the bottom of the control board. There are holes in the PCB where those standoffs line up once it's in position, and on the schematic they're labeled as grounds. Maybe there was an earlier revision where the board was actually screwed into the chassis, which would have addressed my earlier concerns about the design of this amp, and this is just a later revision where they cheaped out. That's just a guess on my part though, so I can't say for certain. Don't forget to hook the ribbon cable back up between the 2 boards. Now slide the amp chassis back into the cabinet from the back and reinstall at least 1 screw on each side to support it. I didn't put all 4 back in just yet, knowing that it would most likely be coming back apart. Once the chassis is secured in the cabinet, make sure to plug the speakers back in. After the first test, it was clear that the jack that I just replaced was not the problem, rather the lifted trace on the PCB, as I mentioned earlier. You can see in this angle here that there is a single trace on the other side of the board that goes from the pin with the lifted pad to the pin on the opposite corner of the jack. With the board flipped back over, I added a wire in replacement of that trace. At first this seemed to have fixed it, but jiggling the jack for a bit showed that although it was now much harder to reproduce, the issue was still present. After that I did some more testing. Since the noise I was dealing with was 60 cycle hum, I was fairly certain this was a grounding issue. If I ran a temporary wire from the jacket of the instrument cable to chassis ground, the hum went away. I checked the schematic and confirmed that the pin with the lifted pad was connected to signal negative. I also found another trace connecting it to chassis ground through a capacitor. So I tried jumpering from that pin to chassis ground, and again the noise went away. So I tore it all down again and got ready to add another repair wire. I located the trace on the board and added another wire from the pin to the capacitor. Because it was such a small component, I decided to also solder to the component next to it to improve the physical strength of the connection. The existing trace continues on to that pin, so electronically this should not make a difference. After this attempted fix, the amp started making a new noise that was present regardless of the position of the input cable. The only difference between now and my testing setup was that the test wire would have bypassed the C100 capacitor completely. So next I removed the wire I had just added and soldered in a new one that went directly to ground. I tried to follow the schematic and do it right, but in this case breaking the rules a little bit is what got me to success. Without that capacitor, there might be a slightly higher noise floor in the amp, but without it in the circuit I didn't notice any difference. As I was tearing the amp apart for this last repair, I realized my worst fear while working on this amp had come true. Several of the pins on the power amp chips had finally given way from all of the stress of holding up the heat sinks. I ordered up some parts and got to work on another issue. One of the tabs that holds the faceplate to the control board behind it had broken off when I first removed the faceplate. Without it, the PCB will flex each time someone pushes the tap tempo button. Thankfully, I had found the very small piece that had broken off inside the amp chassis when I first took it apart and I set it aside. I reattached it with some super glue and it seems to be holding plenty strong. At this point I took the opportunity to clean up the faceplate while it was easy to do with it being disassembled. Some cotton swabs and a bit of isopropyl alcohol make it easy to clean the dust out of those deep corners. Now back to the broken ICs. These are LM3886 op amps, the big brother to the LM386, both made by Texas Instruments. The LM3886 is rated for 68 watts, and in this amplifier there's one for each channel. Each one is being underdriven at 50 watts to get the total 100 watt output that this amp provides. I should have detached the heat sinks from these at the beginning of this repair, and the pins mostly would not have broken to start with. But I originally thought this was going to be a quick in and out repair, so I chose not to mess with them because I didn't have any fresh thermal paste on hand, and I didn't want to have to wait until I did before I could return the amp to my friend. Even though only one of these op amps ended up with broken pins, I decided to replace both of them since the other one experienced similar levels of force. With the amount of times I had this amp taken apart and put back together, much more than what I had caught on camera, I would hate to replace one of them and then have the other one fail shortly after. When ordering electrical components for repairs like this, I like to order more than I need, since the total cost of the components is oftentimes much less than the shipping. For these amplifier chips, they were about $7 a piece, and there's a good chance I won't use them for any future repairs. In this case, I ordered just 3 of them to give me 1 extra for safety. In the case of the audio jacks I ordered earlier, they're a common part that I will definitely use again for other repairs in the future, and they have a much cheaper per part cost, so I had ordered 10 of them. Since I was now going to have this amp longer than I planned, I decided to go ahead and replace the headphone jack as well. As far as I know, it didn't need it, but it looked a little bit corroded and I had the time and parts on hand, so I just went for it. A few days later, the new op amps came in the mail. I had to get a bit creative with placing some various different objects I found on the workbench underneath them to hold them in position while I soldered them to the PCB. I reassembled the amp yet another time and plugged it in to test. This time was a success. Sound was coming out of both speakers, so both channels were working, which meant there were no issues with the newly replaced op amps. After I confirmed that the amp was making sound as it should, I jiggled the cord around a bunch to make sure that the jack was now fixed for good as well. I also noticed that even after less than a minute of runtime, the op amps were quite hot already, so I would not recommend any more than a quick test without installing the heatsinks. With that in mind, the next thing I did was clean off all of the old thermal compound from the heatsinks to get them ready for reinstallation. This thermal paste was not nearly as caked on as I would have expected for the age, so all it took was some light scrubbing with isopropyl alcohol and some Q-tips to get these clean. In order to fit into the chassis properly, the op amps must be angled away from the front panel. I was hoping that the through holes in the PCB would have a slightly increased pitch in that direction so that the ICs would sit that way naturally once installed, but that was not the case. Instead, they stood straight up when installed, and I had to bend the pins to line them up. I wasn't too thrilled about this since the reason I had to replace them in the first place was too much bending of the pins, but thankfully they survived. Once I had the ICs sitting the way I liked and making good contact with the heat sinks, I pulled the heat sinks off one more time so that I could apply fresh thermal paste. I then reinstalled the heat sinks and did another test to make sure that the amplifier ICs had survived their recent chiropractic adjustments. With that confirmed, it was time for the final reassembly. I resecured the wires inside the chassis and put it back into the cabinet. Don't forget the top cover to the chassis, or you'll have to pull it back out like I did. The front panel was quite finicky to get back on, just like it was coming off, so go slow and pay attention to what you're doing. To get the first nut on the front panel, I very carefully pulled the shaft of one of the potentiometers forward with some pliers, and that way just enough threads were showing to get the nut started. I hand tightened it the rest of the way, and that pulled the board forward enough that I could just start the threads on the next one. Then I just worked my way down the rest of the faceplate with this same method. With the nuts back on, I reinstalled the 4 corner screws on the front panel and pressed all of the knobs back onto the pot shafts. The last thing left to do now is reconnect the speakers. My testing after final assembly was more thorough. I wanted to be sure that everything was in 100% working condition before I returned the amp. So I played every sound guy's favorite riff, open string chugs on a drop tune guitar. This gave me my other hand free so that I could adjust all of the controls one by one and make sure they were behaving as expected. Thankfully, I didn't run into any issues there, and I was able to bring the amp back to my friend, ready for lots more music. Thanks for watching, and if you found this video helpful, please give me a like and a subscribe.